Hello sir, today we want to do some presentation. Before we start our group presentation, I want to introduce myself and my group members. First, my name is Fikrideni bin Muhammad Zaini and my matrix number is 05DKM20F1073, and my second group member is Muhammad Kushair Razi bin Hashim and his matric number is 05DKM20F1031, and my third group member is Firdaus bin Idran and his matrix number is 05DKM20F1035, and my last group members is Maxten Line and his matrix number is 05DKM20F1080.
Workshop Technology Welding Defect and Dissociation Welding. Welding defects. The most defects encountered in welding are due to unimproved welding procedure. Once the causes are determined, the operator can easily correct the problem. Defects usually encountered include incomplete penetration, incomplete fusion, undercutting, porosity, and longitudinal cracking. Weld defects are often caused by improved technique or parameters such as poor shielding, gas coverage, or incorrect travel speeds.
Okay, the fish eye. The fish eye, these defects are the silver gray parts of fish eyes which appear in the fractured parts of weld metals. They are produced when moisture absorbing electrodes are used and cooling rate is too fast. Prevention: 1. Avoid rapid cooling of weld metals. Don't use electrodes which absorb moisture. 3. Use the low hydrogen type of electrode. And the last one is pre-heat the job.
The third is crack of weld metal. There is one kind of crack which is caused by shrinkage of metal accompanying cooling of metal. When the properties of steels, restraint of joint and shape of bit are inferior, or when the cooling rate of weld metal is too rapid or improved electrodes are used, these defects are liable to arise. The prevention is: do not use excessive current. Avoid rapid cooling of weld metal. When the rigidity of joint is great, preheating and pinning is required. As another method, it is considered to change welding order. Select the electrode suitable to base metal, especially when C and C are rich. Use the low hydrogen type electrode. Don't use the electrode which absorb moisture.
Inclusion of slangs. The defects are the condition that the slangs are occluded in the weld metals or between weld metals and the base metal. They are produced when welding current is low, speed and manipulation is improper, and groove configuration or root interval are improper. Prevention: 1. Raise the welding current. 2. Operate with proper welding speed. 3. Widen the root interval, and the last one, select the proper electrodes.
The overlapping is they are produced when welding speed is too slow at the state that weld metal does not melt with base metal sufficiently and weld metal put over the surface of base metal. The prevention is use the correct welding current. Second is use the correct manipulation speed, and third, select the proper electrodes.
Undercutting. These defects are deeply cut groove when welding current is too excessive. Manipulation method of electrodes is improper and they are liable to occur. Prevention: 1 is use the correct welding current. 2. Select the proper manipulation speed. 3. Avoid the excessive heating of base metal. And the last one is make the arc length proper.
The occurrence of blowholes. There are two types of blowholes, one which arise inside of weld metal, the other arise on the surface. In the arc length is not proper, excessive current is used, dirty on inferior base metal is adopted, and improved electrode is used. These defects are liable to occur. Prevention: first one is use the correct welding current. Second is make the arc length proper. Third is remove the rust, oil, and moisture which adhere to base metals. The last one is use the correct electrodes.
Distortion in welding. Any unwanted physical changes or departure from specification in fabricate structure or component. Distortion in a weld results from the expansion and contraction of the weld metal and adjacent base metal during the heating and cooling cycle of the welding process. Doing all welding on one side of a part will cause much more distortion than if the welds are alternated from one side to the other.
The introduction of distortion in welding. What is distortion? Distortion is unwanted physical change or departure from specification in a fabricate structure or component. As a consequence of welding,
the first one is angular distortion. Weld tends to be wider at the top than the bottom, causing more solidification, shrinkage, and thermal contraction. For double V H butt weld joint, it depends upon root face and root gap. Fillet weld joint, it depends upon flange width, weld length and flange thickness, and the that is depends upon type of joint, weld path sequence, thermomechanical material properties, and last one is wide and deep of fusion zone relative.
the second is angular distortion prevention. First is reducing volume of weld metal. Second is using double V joint and alternate welding. Third is placing welds around neutral axis. Fourth is presetting by compensating the amount of distortion to occur in welding. Fourth is elastic pre-springing can reduce angular change after restraint is removed. And last one is preheating and post-weld treatment.
Second one is longitudinal shrinkage. Shrinkage in the direction of the weld axis cause preheat or fast cooling problems. Shrinkage stresses in high constraint areas. The prevention is weld towards areas of less constraints, weld short length. Also preheat to even out the cooling rates. Straightening press jacks clamps should be used.
That is transverse shrinkage. Shrinkage is running into or inside a weld transverse to the weld axis direction. The cause is weld metal hardness problem, constant applied to weld joint. The transverse shrinkage is butt weld is 1.5 to 3 mm per weld to 60 degrees V joint, depending on numbers of runs. The fillet weld is 0.8 mm per weld, where the leg length does not exceed 3 out of 4 plate is thickness.
Transverse shrinkage have two. The first one is butt welds. It was 1.5 to 3 mm per weld to 60 degrees V joint, depending on number of run. The second one is fillet welds. It was 0.8 mm weld where the length when the leg length does not exceed 3 over 4 plate thickness. The fourth one is rotational destruction. In this sheets being but weld either come closer to each other or the distance between them is widened. Depends upon thickness of parent material, the temperature difference between a mortar pool and the unheated parent material, different in heat flow, speed of welding and heat source. Rotational destruction have two. The first one is progressively welding material at widely different heat inputs and expanding and contracting zone in arc butt welding. Number 5. Boiling or longitudinal bending. Weld line does not coincide with natural axis of a weld structure. Longitudinal shrinkage of the weld metal induce bending moments. Amount of distortion depends on shrinkage moment and resistance of the member to bending. Number 6 is buckling distortion. When thin plates are welded, considerable residual stress occur in areas away from the weld and cause buckling. Occur when specimen length exceeds the critical length for a given thickness. Amount of deformation of buckling destruction is much greater than that in bending. 7 is twisting destruction. Twisting is due to low torsional resistance on thin material. When a weld is made along the center of a member, the weld area tends to shrink and become shorter. To certify the condition of a member has outer edge longer than its center line, the member must twist. Lastly is bucking and twisting distortion prevention. First is minimize shrinkage by decreasing volume of weld metal and highest computable speed. The second one is keep the length of the weld member as short as practical. And the last one is incorporate torsional resistance of twisting as much feasible.
Hello, my name is Maxtin Lai. In my presentation today, I want to talk about how to minimize distortion. Okay. Step 1 is do not overwhelm. The more metal placed in a joint, the greater the shrinkage force. Correctly sizing the weld for the requirements of the joint not only minimize distortion. The amount of weld metal if filled well can be minimized by the use of the flat and slightly covered plate in a bar joined by proper edge proportion and fit up. In general, if distortion is not a problem, select the most economical joint. Step 2. Use intermittent welding. Another way to minimize weld metal is to use intermittent rather than continuous weld where possible. For attaching stiffness to plate, for example, intermittent welds can reduce the weld metal by as much as 75%. Step 3. Use as few weld pass as possible. Fewer pass with rust electrode are preferable to a greater number of pass with small electrode. Shrinkage caused by each pass tend to be cumulative, terribly increased total shrinkage when many pass are used. Step 4. Place weld near the neutral axis. Distortion is minimized by providing a smaller leverage for the shrinkage force to pull the plates out of the alignment. Both design of the weldment and welding sequence can be used effectively to control distortion. Step 5. Balance weld around the neutral axis. Offset one shrinkage force with others to effectively minimize distortion of the weldment. Design of the assembly and proper sequence of welding are important factors. Step 6. A well-planned welding sequence involves placing weld metal at different points of the assembly so that as the structure shrinks in one place. An example of this welding alternately on both sides of the natural axis is making a complete joint penetration. Okay, just that for my presentation today. Don't forget to subscribe our channel here